Okay, so our goal today is, it's a little like geometry proofs, only much easier, much easier. So I always think about draw a line down, and what your task is you're gonna manipulate the guys on the left side to make them match the guy on the right side. So I basically gave you the answer. Remember on the first day where you'd have to simplify and match up? Well, now I'm telling you what the answer is, and you have to show me how to get there. So your steps are really important, right? If this were a regular year and I were grading your work, it's all your work I'm showing. So when you see secant, you don't like that, right? You want to get rid of it. So who is secant? 1 over cosine. So you show every step, and that's like the equals. My advice is never change the right side. Every once in a while, you'll get a problem that's kind of backwards, and you can really see where changing the right side will make it match the left side. And that's not wrong. It's just for the most part, if you change both sides, you end up with a mess because you don't know where you're going. So don't change the right side. Now, what's 1 over cosine times sine? It's sine over cosine. And what is sine over cosine? Tangent. And that's your goal, to make them look exactly the same. So you're manipulating that right side, left side to look like the right side. Does that make sense what we're doing? It's like a geometry proof, except you don't have reasons over here. You're not writing your reasons why. You're just showing. It's kind of like unmasking someone, the masquerade ball, right? Yeah. It's like, or like you're in court and you're trying to prove this guy is really that guy and he's guilty. Or this patient came in and he says he has this, and you're going to go through and see if that's really what's wrong with him. If you want to use your imagination and be crazy like me, that's things I used to do. Okay, what do you think we should do with sine squared minus cosine squared? Do you recognize that pattern? What is that pattern? I want 3 words. What is this guy? I want you to always see him for who he is. Yes. We like a difference of squares because it means I get a plus and a minus, right? And that happens like x squared minus 49. This is sine squared minus cosine. So I can factor that. Sine x plus cosine x. Sine x minus cosine x, right? All over. Now let me ask you a question, because I don't want you to get frightened as a kid. You kind of have to choose a path. You have to try something. Do you think on every single problem you do, you're always going to start the right way? No. So if you try something and it starts to make a mess and you're like, this is not doing anything, just draw a line through it and start a different path, right? You have a lot of substitutions on this sheet, and you may pick the wrong one. You might pick cosine over sine for cotangent, and maybe you should have picked 1 over tan that time, right? So just try something, anything. If it doesn't work, go back to the drawing board. Okay, what do we know? What do we like about this setup right here now? Yes, these guys match. So now, oh, we're done? You mean that's it? Well, that was ridiculous. That was just too easy, right? It's easy because I guided you through what I knew to do. When you're faced with these on your own, you got to try something. So what could you try? When you have to do these, let's make a list of things you could try. What did we do here? Starts with an F, A, C. Try to factor. Does factoring work? Maybe factoring doesn't work. What else could we try? What did we do here right away? Substitution. Well, we haven't done anything else so far. So does it help as you come up with techniques to make a list of what worked? Yeah. Then you can look back at it. Eventually you won't need that. Okay. Oh, now here's this. Now let me ask you a question. This is important. Usually when I have tangent or cotangent, I might like to try to turn them into sines and cosines, right? But I notice there's tangent and cotangent over here. So do you think I should get rid of them for sine and cosine? I don't think I should. I could, but okay. So what do you think we should do when we have fractions? I think we better add this to our list. What do you do with fractions? Get a what? Get common denominator. All right. How do I get a common denominator? Multiply this side by cotangent over cotangent. Multiply this side by tangent over tangent. Because tangent over tangent is really 1. Cotangent over cotangent is really 1. And then I have a common denominator of tangent cotangent. Yep. What do you want to substitute? Well, yeah, you could. You could. Let's look at this way. This actually easier. Okay, so 1 over tangent is what? 1 over cotangent is? That way works too. Good job. If you went through this way, you would end up with a common denominator where you would have a little bit of work to show. Like it's basically the same thing. I'll do this way also. This is fast. So here I would have cotangent over tangent x cotangent x minus tangent x over cotangent. I'm going to put them in order. Tangent x cotangent x. What is tangent times cotangent? 1. So it's cotangent x minus tangent x. Right? There are always, or usually more than one way. They're like geometry proofs, right? All right. Good job. Excellent work. What should we do with this guy? Now think ahead where you're going. Cosecant comes from sine, correct? Cosecant is 1 over sine. So we know we don't want to get rid of the word sine, do we? So what do you think we should do with this? Well, we don't want to change that side. You could get in a big mess. Let's manipulate this side. Do you like these two together? Does cotangent have another name? Well, but then I have a tangent. Is there another one? And what did this do? Now, what should we do? This is really over 1, so what should we do there? Well, this is added. It's not multiplied, but can we get a common denominator of sine? Is this starting to look good? Do you like it when you have a sine and a cosine squared? So this is now what? sine squared x over sine plus cosine squared x over sine. And what is sine squared plus cosine squared? 1. Right? Cha-ching. When they match, should really be. Okay? Look at the word when you're trying to prove these. Look at the word that's on the right side that you're trying to get to, and try to get rid of words that don't match or don't help you. Most of the time, we like to keep sines and cosines if we have them. Those are easy, friendly. We know sine squared plus cosine squared is 1. We knew tangent did not fit into this grand scheme of things, right? All right. Now we're just practicing. You get the idea, so let's practice. Is this one true? Will this take a lot of steps on E? It will not, because remember though, your goal here is to show me how this is true. So it's all your work that's important. It's not the answer. I'm giving you the answer. So how could you show me this is true? What is cosecant? So that's sine t over sine t. Now, if I were just doing homework to find the answer, if I didn't have the 1 given to me and I was just looking for the answer, I could probably go straight to 1. But the purpose of the identities of what we're doing today is, can you show me the work about how your mind got there? So you're showing me what's inside your brain. So that's why we're writing them all down. I'm not even going from here to here. I like you to see that. And it's also good practice with a fraction, right? All right, what about F? Any ideas? You've got 2 things multiplied. So what do you think you should do? Multiply. What is the relationship between these 2 things? What are they called? It was, but what is this compared to that? It's something you do to your verbs in Spanish class. They're conjugates, right? And I want you to always recognize a conjugate. A conjugate means that the first and last are the same and the sign is different. Because when you FOIL these, what happens to O and I? They zero out because one will be positive and one will be negative, right? So if you recognize a conjugate pair, it's a common tool in math that we use to get rid of middle terms. Multiply by the conjugate helps us rationalize, get rid of radicals, get rid of i's. So always recognize that pair, because then you don't have to do FOIL for FOIL. You just have to do F and L, right? So if, can you say FOIL without the OI? Okay. Yes, ma'am?
Can you also just simplify them? How like 1 minus sin x equals cosine?
Well, you don't have a 1 minus cosine squared. It's 1 minus sine squared. That's a Pythagorean, not, no, it does not. It's from the Pythagorean theorem. So when you have reciprocals, right, like 1 over sine and all that, you can cube them, square them, whatever. But when we talk the Pythagorean identities, these fellas down here, they only work with squares because that came from the Pythagorean theorem, so you can't take them out. So recognize a conjugate pair in math that shows up all the time, and that means we just have to do 1 minus sine squared alpha, right? And now we can go to the Pythagorean identity, and who is 1 minus sine squared alpha? Cosine. A lot of the things that you learn in algebra 1 and 2, like a conjugate pair, it's just too much to learn at once and you can't remember everything. So this time around in pre-calculus, you want to hone in on those algebra skills and be like, oh, I see the pattern. This is so easy now. All right. What do you think we should do here? Anytime you see something squared with a 1, yes, sir? Sure. Anytime you see something squared with a 1, you're going to go where? To your Pythagorean list. Is secant squared x minus 1 on that list? Oh, it's right there. So what are you going to sub in for secant squared minus x? Yes, you are. Now, y'all are all okay with the variable y. We don't care what variables there, right? Theta, x, y, beta, we don't care. Okay, what is cotangent? I want you to see that anything times its reciprocal is 1. But remember the goal with these? I'm trying to see what's in your head. And if you go straight to your answer, I don't know what's in there. So you're kind of learning a technique here. Because in future years in your math class later, these can get harder. And if you're not used to the steps. Cha-ching. All right. What do you think we should do on this one? Now, I can't help but notice I've got two things squared. And when I have something squared, I know it's on that list. Now, I don't think I want to get rid of both of them. Which one would you want to get rid of this time and why? Yes, I want to get rid of cosine because I see my answer has a sign in it. So what can I replace cosine with? Okay, what is 1 minus sine squared minus sine squared? 1 minus 2 sine squared. And I always put a check mark to make sure the right match the left. So these aren't too bad. They can get bad. I can make them that take a whole page just to keep working your way down. But that's for a later day, right? We're doing the beginning ones now. Okay. What do you want to do with this one? Well, this one's pretty much done, isn't it? What is secant? All right. I'm going to pause this and let y'all try to do this one all on your own, and then we'll come back and look at it. Okay, so we're going to try this. Now, when you have a 1, what's nice and magical about a 1? How can I rewrite 1 so it looks better with this fraction? How about 1 minus sine over 1 minus sine? What's the advantage of that? Now I have a what that I need with fractions? Common denominator, right? So now I have what? What do I have? What mess do I have up there? Cosine theta, whoops. Cotangent theta minus 1 plus sine theta all over 1 minus sine theta, alpha. What do you think we should do? Which word bothers you the most? Cotangent, right? So what could I rewrite? I'm just going to erase mine because I'm going to run out of room. How could I rewrite cotangent? So what I really have now is cosine squared alpha over sine alpha minus 1 plus sine. Can I get a common denominator here too? Instead of writing 1, what can I write? What can I write instead of 1? Sine over sine. Now, instead of writing sine with a common denominator, what can I write? Sine squared over sine. True? True. Now, what magic pair do you see in there that you love? What is cosine squared plus sine squared? 1. These two together make a 1. So what I really have, okay, cosine squared plus sine squared is, I'm so sorry to be going this way, is 1 minus sine squared, or sine, all over sine. And what does this symbol mean? What is this big bar? Divide. Instead of dividing, we do what with fractions? Multiply by what? Oops. Right? Now what happens to these two guys? And I'm left with what? And take one more step and write that out. So that was not that hard, but it's asking you to mess around with fractions. And I know sometimes we aren't best friends with fractions, right? Okay. Are we good? We are good. Hopefully everybody watching had fun.